Hi everyone. Today just we are going to learn about the resilience in Java application. Before going to the deeper part that how can we implement resilience in Java, we will just understand what is resilience basically and why it is necessary in today's application to have resilience based technology because if we want to stop a Java application from the failure or any kind of stoppable things in future, we have to just make it kind of handle those failures or maybe avoid those failures. I will just show all these things via one uh, presentation. We will go step by step through that. I'm sharing my screen. I will just show you how we can achieve that. Hope my screen is visible. So the main topic for this slide is the designing for resilience pattern for fault tolerant Java application. If we are coming through through new things, then we have certain kind of pattern in Java. If we are talk about the solid principles, there are some pattern for that. If we are going to the design patterns, things are designed in a pattern. So if we talk about the designing of resilience, there are some pattern for that. And it can be a fault tolerance. We will just learn step by step for that. Sorry. So first of all, what is resilience? And then we will go to why fault tolerance matter in a Java application. Then we will just understand resilience in Java application. Then we will just go through the design pattern one by one. Then we will just learn about the tools and implementation for the same. Then we will just wrap up the things. We come to the first slide. What is resilience? So if I talk about the technical term wise or like theoretical part, it's a kind of a software system, especially I'm talking about the Java application. It's the ability of a system or to withstand or recover from failures by continuing to operate even if it is in the degraded mode. I'm just talking about like if a system is going to failure in future, or maybe some occurrence is about to come, it should be capable to handle those failures, or it should have some kind of solution to come up with the come up with such kind of failures. Suppose I'm just going through a payment website and maybe Flipkart or Amazon or maybe some any kind of shopping website, and where I will, if I edit the items to the cart, but when I am going to the payment part, so somehow it got failed. Maybe bank service is not available, or I just enter the wrong credentials, or something happened to the system in between. It broke down. What happens nowadays? It provides us a retry. Okay, payment has been failed. Do you want to retry? Rather than whole things got failed, we are just have a capability to recover in between. So we can just retry with the payments, and it can be achieved. It cannot be failing. Okay, my cart attempt deleted. Like this thing will not happen. You can just make a payment again, or it will give an option of the retry also. You can use the maximize threshold of 5 or maybe 4 time 3 time. Then only it will be considered as a whole failure, not in the between. So this is a kind of resilience we have to have in our system basically. What are the resilience key aspect? Maybe some kind of, I told you the example, maybe system may not perform 100%, but it works instead of crashing completely. Sometimes system does not fail completely, it just part of the system got failed. If something is able to recoverable, that thing works. Maybe if we are having 5 components in an application, so 4 components got failed, so one component will be work in the working state, so that is called a graceful degradation. Second things come as a self-healing. So system can recover from failures automatically without manual intervention, like retrying or field services. So sometimes we have seen refreshes on the page happens in between automatically if something got stuck, or we are on a maybe booking any tickets. So we see sometimes it got refreshed automatically. So we have no need to do anything. We don't need any manual intervention. We don't need to any retry failing services in that. That is called a self healing. That is also kind of resilience based system. Then things come for the isolation. So maybe failures in the one part of the system should not cascade into the other areas. So I just explained in the previous example. If I'm just keeping the payment flow. I'm just going suppose example of the Uber ride. So user is booking uh, ride through Uber, and he booked a ride, but somehow in between, while sitting in the car or any like vehicle which he or she has booked, the payment service is not working. So means the application was capable for the user to make some of part of available, but some payment work is not available. So driver will have option to their end admin side, or driver will have another like user login for them, so they can initiate payment by cash. They can change the pattern for the cash, and user can give the cash to the driver. So this kind of things are very helpful because it does not crashes anything. No one was in loss, neither the driver nor the the person who is traveling. So this kind of applications makes the user application experience better. If suppose user has selected payment as uh, GPay or maybe credit card, not with the online banking, but the cash option is not there, then driver and the traveler both will get stuck, and they have to compare to a site, and back and forth thing will happen. But this situation is handled and the user and only, nothing to be worry about in that case. Then we come to the fallback mechanism, means we have to come to the provide alternate solutions when primary function fails. So we just use a cached values, means something which is previously stored. We have to use those values for the fallback mechanism. So so cache data or default values which we were using, so we can recover the things. Maybe sorry, we can just store the username and password and use them like this. So as I already told you, why do we need resilience in our system? So because failures are inevitable, whether due to the hardware fault, network issues, or third-party service down, or bugs. Without resilience, these failures can cause system-wide outages, loss of revenue, damage of user trust. As I already explained in the example, if I'm working on a system and the I'm adding the item, okay, am I 2 3 hours of time went in searching the items and adding in the things, then system crashes or I'm not able to do payment. So it provides alternate solution. Okay, net banking is not working, you can go through the debit card, or in the retry mechanism you can make the payment again with the selected payments, or you can have multiple options for that. And for the another side, for the clients also, it is a loss of revenue will not happen. Okay, user will be stick on the screen and they will just make a final payment, or not about the payments, like they will have a better user experience for a website. If you're registering to a website and okay, I filled up all the information, something went wrong, system crash, okay, now where is the information? So in that case, the resilience is in useful. Cache data is there. Somehow, system store the information of the user, whichever user has filled. Maybe 3 step, 4 step he has completed. We can reproduce those steps and get the data basically. So in those cases, resilience comes in the picture. And nowadays, every system, maybe it is a Uber, Netflix, or any kind of system, they are using resilience. In the Netflix also, buffering is there. So like if some net speed is not working, or something slow down from their end, so we will have the buffer data, so you can download the video, or maybe maybe save the videos in your end. So these kind of things come under the resilience pattern. So why fault tolerance matter? In if we talk about the resilience, means we are having ability to adapt the failures. Means before happening anything, we are just able to handle that thing. So it is a kind of ability to continue operating properly even if one or more its components fails. So for that case, what we do, we just have the multiple CPUs. Maybe one CPU got failed, we have another one. We make this distribute kind of system. If something is running on the one server get fails, it just move to the another another system. So these kind of things comes under the fault tolerance. So what is the what are the benefits basically? So it will minimize the downtime, means the less disruption and fewer revenue losses during the failures will happen. Something went failure on the one database side, another database will be up. So if you have seen any application, if I'm seeing my daily like measurement for store data, if I'm storing my store data, I want to see okay what is happening in my store, and I do have an analysis site for that. And for that site, something went down on a system, one service got failed and something happened in between. But we should have another database for the same thing. We have another CPU, we have another memory reserved for that, we have another instance for the application. So that will start running and we can see the data on the another side. So it is minimize the downtime. It reliability, it increase the reliability. So suppose one thing is not working, another thing is working. So it will the trust for a user also and for a developer also, or the client also maybe. So if I'm giving an application uh, to a user and he or she face some kind of issue, so trust can be maintained and they will not be go understand. Scalability. So if we do have such kind of fault tolerance system, one got failed, another is working, it grows up our system. So maybe now I have a 10 users and another 100 users may come in future. So it will have those kind of accommodation within it. So it can just grows with the system without compromising the stability. Okay, now I'm using 3 CPUs, I can use 4 one. If I'm using 2 instances, now we can grow up with the instances. And the cost effectiveness means if something got failed and we are trying to recover this from the starting to end, it is a cost effective things. And we have to start from the beginning, from 1 2 3 to 10. But if something is broken from 6 and we can recover from 5 to 6, then it is a better thing for us. And for this, we just got into this one more thing, Exxon server, that is also made for the these like FIs only, for the Flipkart and these commercial websites only, e-commerce websites only, where most of the cases payment got fails. So for that, it is a kind of a different thing. We can just make another video for that as well. So that is a kind of a thing where we just get the rollback kind of things. So, first of all, we will just understand the resilience in Java application. It's a first class concern. Means, first of all, if we are designing an application, so designing with the failure in the mind. First of all, whenever we are starting any application, we have to just make in our mind, okay, this can fail in this step. So, what will be my steps for this thing? So, this is a first class concern, and we should identify the network failure, like what are the common causes. In common causes, I just already told you, maybe network at latency issue. In some places network is slow, maybe some places it is strong, but maybe slow at the same time. So this should be in mind. Database connectivity issue means it is not connecting with one database, then we should have another replica running on the another CPU or another system, another server. So that issue can also occur. Third party service updates, if I'm using a third party library in my system and that got failed, in my if for example in my application I'm just doing the credit card payment, and and I'm using another website. Suppose I'm using Amazon for water bill payment, but the website of water bill from where it is fetching the water bill which I need to pay, that is not working. So in that case, what I should do, that is also comes under the common failure point. So that should also be That should also be manageable, handled in our application. Resource exhaustion are typical failure scenario in Java application. Like suppose my application requires 2 GB, but I am just allocated 1 GB. Then the slowness will be there, or resources will be exhausted. So these kind of failures should also be part of resilience. So for that resilience trade-off, we require balance of complexity, performance, and fault tolerance. Each pattern comes with a cost that must be weighed against the benefits. So if I'm just trying to implement any pattern, so suppose I'm just retrying 5 times, 6 times, 10 times. So it is a kind of a cost-effective things. So that should also be keep in mind. Okay, I cannot use any pattern blindly. Like if I have to use one pattern, so I should keep in mind why I'm choosing this one and what will be the benefit of using this. So we will go through the patterns one by one, then we will get to know about that. So next slide comes for the religions design pattern. So core patterns are circuit breaker, which is mostly used. So it is just prevent the cascading failures by stopping requests to failing services. What it will do, it will just stop the request for coming from the user for failing services. It will not accept the requested after a certain period of time. That is a circuit breaker, means it will break the things in between. Rate limited. So suppose it will just limit the like it will just restrict the number of execution to prevent overload. Okay, suppose one site can I just get to know by running a website, okay, this website can handle these many kind of requests or this much of load at a particular time. So I will just make a rate limiter in that case. So for implementing in Java, we will just set it in the application YML file. Okay, this kind of this many rate limiter it can use. I will just show you in the example for that. Then it comes for the retry pattern. So automatically how many times we have to retry for something. So I told you the example for the Amazon. Like if you are trying to do payment, it will just provide a retry option for doing the payment also. Then timeout also, like in retry we just have the configuration back of strategy. Then timeout. Okay, limit the duration of the calls to permit resource execution. We will just limit the duration. Okay, you can just be on the system on 20 minutes or 30 minutes kind of duration. We set in the timeout pattern. Bulkhead. So it's a kind of a circuit breaker pattern, but it is just isolate failures by limiting the concurrent calls to the services. Means like it just limit the concurrent calls. It means like when whatever service is calling step by step, it just stops that thing. So in the circuit breaker pattern, we just have the two state, open state and the closed state. So it will just define in our application. Uh, we just have the closed state. So this state allows the request pass through normally. A failure counter track unsuccessful application. So closed state means we will just allow the request. Okay, you can just pass through this network. But when failure exceeds a threshold, we just give in the number of threshold. So the circuit opens, failing fast without attempting potentially futile operations. Means so when it is an open state, the uh, failing fast will be happen and it will just stop the coming request. So this is a open state. Then we come to the half open. So after the configure timeout, the circuit allows a limited number of test requests to determine whether if the underlying issue is resolved or not. Means it will check, okay, it is half open, means uh, we have just some kind of open, some kind of close also. It will just keep checking on that case, whether we need to open it or close it like this based on the configuration timeout. And then we come to the implementation part. It just requires a resilience 4J library. So that is ready to use circuit breaker implementation for. We have to use resilience 4J library. I will just tell you how to use that in our with minimal configuration. How can you use that? Then another one comes as the retry pattern implementation. So in the retry means we are just trying to do something again. So application attempts to execute the operation for the first time in the initial attempts. Then In the retry, it comes to the failure detection. Okay, system identify recoverable errors that warrant retry attempts. It got to know, okay, some service got failed, so it comes to the back of strategy. Exponential back of increase wait time between the attempts. Like it just increase the time for in between the back of strategy. Then come to the retry execution. Operation is attempted again with the appropriate contents preserved. So retry pattern is particularly effective for the transient failures in the network operations in distributed systems. Implementing proper back-off strategies prevent overwhelming already struggling sources. So first of all, it just do the initial attempt, then it will okay get to know this is a uh, okay, failure can be come in the in failure has come, okay, something wrong happened in the system, then it come, okay, increasing the, it will increase the time, for this much of time it can be increased, then it will do the retry for the same thing with the contents preserves. So this is a retry pattern. So there is a no. So in the circuit bit, we will having the half open, half close. Okay, these when requests can come, but in this case, it will completely retry the particular failure things only. Then we come to the bulkhead pattern. So bulkhead pattern. What is the meaning of bulkhead? Means something is bulky on our head. We will just get to know about that thing. So bulkhead pattern isolate components of an application into a pool so that if one fails, other will continue to function. Named after the compartmentalized section of a ship hull. So pattern is essential for preventing cascading failures across your entire system. Ensuring the resource exhaustion is one area doesn't bring down the entire application. So it means to say that it will have a uh, it will just separate the things. Okay, this component is working for this service and this component is working for this service. So we just divide the things, means like modularizer things. So if one things comes fails, we will just open up with the another things. So what will be the implementation approach for the same? So it will be used during the Java, maybe thread pools or the separate connections. Java is making the different instances, DB instances maybe, or maybe your service instances. So we can use the Resilience 4 libraries or maybe Hystrix library for declarative bulkheads. So suppose for this thing, maybe like this is a kind of a cost-effective things because we are just using the separate instances for everything. But for future use, for just making a system for handling such thing, it is a good approach. So bulkhead can be I just discussed by the thread full with the fixed size of different services. We will make a thread full of fixing the size of like different services. Like we are having three services, so we will just make a pool of three services and with a fixed size. Okay, one service got filled, we will just pick up the another one for the same services. Then we can, another thing, we can just separate the connections pool for different database operations. For the database also we can make separate connection. We can isolate Java instances for the critical components. As prefer as the I've seen many applications, the database part is the most critical one. So we can make the isolate the JVM instances in that case, and we can use the Resilience Forge or Trix libraries for the declarative bulkheads. Then it is a last one is not the last one. Yeah, last one only. The timeout and fallback strategy pattern. So what is that? So we just make a timeout things. Earlier we had circuit breaker, it is an open closure state. Then we come to the retry. We just make a retry after some time. Then bulkhead, we make a thread full size. Then another last one comes as a timeout and fallback. Means we just set the appropriate timeout. Means like we just uh, define the reasonable limits for an external calls. So we can just means like we have to define the limits of the time. Means for these much of time we will just wait for a service to complete the execution. If it will fail, it will be timeout. and then we can just implement the fallback behavior. Means we will just try to provide the fallback, means going back. So provide the alternate responses when primary methods fails. We will just, if something gets failed, we will just try to another things to the user. And third thing comes as a cache previous responses. We just use the stale data when fresh data is available. So if you have seen in the website where it is going to show you the analysis of some, maybe some website, or like some kind of maybe I can say, maybe store information is there. Okay, what is happening? How many sale is there in a particular day? How many people visited in a day? So whole data is being shown. But if it is not able to fetch the refresh data, so what it will show? It will just show you the previous cache data in that case. So it will just show you the previous responses. It will not show okay site is not available, or we are just not will say show you anything. So proper timeout configuration is critical for preventing resource exhaustion. Without timeout, a slow dependency can tie up all available threads, leading to cascading failures throughout your application. The most robust Java application combine timeouts with appropriate fallback mechanism. So if you will see in the most of the application, we do have a fallback mechanism also. We just provide the alternates or responses when primary method is not available. So consider implementing graceful regression by returning cache data, default values, or simplified responses when the primary operation fails. So uh, I can give you another example, like if you will see, um, if I'm just moving, I'm just browsing the data, and if one click is not working on the navigation part, so it will be on this, while refreshing the data, I will just try to navigate to the another page for which we are just clicked, but somehow that service is not available for which we are just trying to go. So what happens? It just stay on the same page and it will show you the same thing another time. So these kind of things comes under the timeout or fallback strategies. For that, we just use the cache data and default values, or maybe simplified responses. Maybe it can just show you, okay, we are working on it, or maybe you can see, okay, you can browse another thing in the same time. So these kind of things are already handled in the applications. And nowadays, we do have such kind of applications where timeout or fallback strategies are being used very vastly. Means it will not show you the failures of application, it will just show you something else, or maybe it will stay on the same page with the old data. So this is a very good thing. It will just keep user interacting with the things. I have seen some sites block you in another location, but it will just not hold you from browsing the things. Like if you are trying to access one website to another location and it is stop, it is just firewall is there, or it is not stopping, but you can browse the data. Okay, what thing is available on this website? So it is not stopping you from the things, but it is just being on the same page for you. So this is a kind of a timeout and fallback strategy pattern. So now we will just how to perform Agilist testing. So as we just write the unit testing, integration testing in Java application, then we just go to the Chow's engineering. So we have to use a Chow monkey tool in that case. So for unit testing, map dependency to the simulate failures, verify retry logic with the control exceptions. So what we have to do, we have to just verify while writing the unit test cases, we have just check, okay, we do have a retry logic with the control exceptions, test timeout behavior with the delay responses for the timeout. Like we have just given the 250 milliseconds, so we just increase it for the 500, and we just write the test cases like that, so that we can just test, okay, retry logic is work, so timeout exception behavior is working. And for the baker pattern, we just identify the open and close state transition, in which state it is working, in the open, close, or half open closed state. So these kind of things come under the unit testing part. If we come to the integration testing, the test we have to test actual service integration interactions. We have to use like wire mock to simulate dependency failures and verify end-to-end behavior during failure scenarios. For integration testing, we have to go through the like one end to another end to identify the failures. Okay, these can be the failures and what prevention should be taken care in such cases. So that should be implemented in our code. So this come under the integration testing. Then comes to the chaos engineering. So introduce the random failures in the production like environments. Maybe something goes good in the dev test or maybe UAT, but we have to just test for the production environments, the random failures. And we do have another tool like Chow Monkeys for the Spring Boot and gradually increase the failure complexity. So these kind of things come under the chaos engineering. So now we will go through the implement the resilience 4 in our Java application. So we will just use, sorry, we will just learn step by steps for the same things. So how can we implement resilience 4 in our Java application? So first steps comes as like dependencies. I already told you what we have to do. We have to just include resilience 4J module in our Maven or Gradle configuration. So there is a build.gradle file or maybe pom.xml for the Maven tool. So we can use the resilience 4 module. There are core modules are resilience 4 certificator, retry and for bulkhead for the time limiter. So these are the four core modules for these dependencies. Then we have to just configure resilience pattern. So for that, what we have to do, we have to just set up. We have to set a appropriate configuration for each pattern, specifying threshold, timeout, and other parameters that matches the application requirement and the SLAs. Okay. Then we have to just apply the decorators to our controller and services. Wrap up the service method with the appropriate resilience decorator. Combine multiple patterns when necessary and consider using annotation for cleaner code in Spring application. Then we have to just monitor then adjust. Integrate with a metric system to track resilience pattern behavior. Maybe we can use data or Kibana, whatever tool we want to use, and use the data to fine tune configuration based on real world performance. So we will just get started with the resilience for application. So for that, first of all, add the dependencies. So this is a Gradle file. So we have just added circuit breaker, implementation, resilience 4J retry, maybe another core module, set up the configuration model for each resilience, then apply to the service calls. So we will just go through the real-time example for the same. So as you can see my screen, I have made the controller, exception, services, and my main file.java. So first of all, I will just go to my build.gradle. So in this, this is a normal Spring Boot application, Spring Boot version. And if you come to the dependency part, so here I have just used the reactors, resilience 4 reactor, resilience 4 all for adding the all. Then this is for the another things. And then I come to the main file that is application.yml. So in this, I've just made for the retry and for all. I just made it the configuration for all. So in this, so it is running on the port 1980. So I told you for the circuit breaker, I will just breaker. We will just define the health indicator true and like permitted call of half open state 3 till 3 it is a half open state, then it will go to closest open state. Sliding windows, minimum number of calls, wait duration of open state, thresholds, event buffer size, record exceptions. So these kind of things you have to do the configuration. Then sliding window size, permitted of calls of half open state, how many number of calls it can permit to the half open state. It is 30, 30. It is just trying for 30. Maybe it is more, but we can reduce it also, maybe increase also. Failure threshold, wait, how much time of seconds of wait it in the open state. Event consumer buffer size, ignore exceptions. Okay, these kind of ignore exception comings, then it should ignore this thing. In the default, this is a default configuration, this is a shared configuration. So if we come to the instances size, so it will be based on the config side. So it will just define uh, base config register integrated true, sliding window size 10, minimum number of calls, then permitted number of calls, wait duration open state, failure rate threshold, and event consumer buffer size and record failure predictors. And then we come to the retry, how many times are retry. So maximum of attempt. So this is the default configuration. How many maximum attempts are required? Wait duration, how much is the wait duration? The retry exceptions. These can be the retry exception comes. So we will go to the exception part also. I will just show you what is this is a business exception. I already told you. Then this is a record failure exceptions, and we have to just ignore the business exceptions. For this also we just make the instance base config default, base config defaults like this. Then come to the bulkhead part. Okay, in the bulkhead it is a kind of thread pooling using. So we have just make the thread pool bulkhead. So maximum concurrent call 100 and current call 100, time is 20 and time is 20. Like this we will just make the thread pool size 2, or core thread pool size 2, like this. Instances backend based configuration, like this we have made. So maximum thread full size, core thread full size, and queue capacity and base config is difficult. Default, sorry, not difficult. And in the resilience for rate limiter also, we do have health indicator false, limit for period, limit refresh period, timer set duration, event consumer buffer size 100. Instances base config, backend, limit for period, limit like this is for the rate limiters. So limit for period 6, limit fresh period 500, timer exception 3 seconds. And this come for the time limiter, last one. So in this also we do have default configuration, how cancel running future calls, timer duration 2 seconds, backend configuration default, backend is defaults. So like this we can just make the configuration for all type of patterns. So based on your application you can just define which type of pattern you want to use an application. Mainly for the like e-commerce websites, they go to do the maybe fallback mechanism mainly, or maybe with the bulkhead, not bulkhead, fallback is mainly used, and like circuit breaker is also used in that case. So this kind of configuration is needed for our application. So I talked about the exceptions. So this is a business exception which we have to ignore, and this is a record failure prediction. So this example I've taken from the robot wrinkler. So uh, just try to ignore that as of now, because I've just taken example and downloaded it from the GitHub. But it was a good example for showing to the whole overview for this thing. So these two type of exception I've just written. So and this is a backend controller. So in this I've just made different services for the failure, success, for success exception, for ignore, for no success, mono failure, flux, screen, mono timeout. So these many type of services are there. And for the B controller, I've just defined failures for the same success exception. These many endpoints will be there, and in this I've just overwritten the things. Okay, this is a uh, constructor for initializing all the services. These registry application, thread pool bulk registry, circuit breaker registry, retry registry. So for all kind of pattern, we do have the registries. So this is showing the timeout registry, rate limit registry, like this. And for this, so suppose it is showing business B or service. So then business B like this. And if you come to the downside, okay, execute with a fallback. Okay, it is there. So it will just timeout operator of bulkhead operators. So you will see for each pattern we do have the breaker operator. Then execute with fallback is another thing. So it is a for error for resume, and this is for transform. Time limit operator for the time limiter. Then bulkhead operator for the bulkhead. Then we do have the error resume for the same. So And then we come to the execute last part with the circuit pattern with the bulkhead. We just passing this object, this circuit breaker object, this bulkhead and the retry. We just executing this thing. Then we just have the executor async part with the time limit bulkhead with the time limiter circuit breaker with retry. We just trying to execute async and execute async with fallback. We do have we just passing this thread bulk rule object here, then schedule time limiter, circuit breaker, fallback. These are passed in the execute async with fallback. So this is how we have to just make a backend B controller for defining all these things slash backend B. Then we do have a backend C controller. Here also we do have all the calls. It will just return success, failures for the business C services, whatever we have made in the C service. So this is the A service. It is just defining the simply the failure class. Okay, this is a remote exception. This is ignored by circuit breaker. Hello world from the backend. Like this. This is a remote exception. Flux annotation. So these kind of services are there. If you will see, so main part is this one. We have to just give the circuit breaker name here. The time limiter bulkhead name. So this thing we have to give in our application. Then we come to the backend B part, same thing. We have to just give the bulkhead name like this. We are just defining the all the methods which we define in the controller part. Then backend C service, the same circuit breaker pattern. Then bulkhead, what we do a bulkhead, and the retry, what we have to do for the retry pattern. So this is the time limiter, then circuit breaker, override, circuit breaker pattern like this. We have to just define these things. Then service.java, we just having the simple calling of the methods in this class. Then this is our main application. So I will just build it and just test how the endpoints are working. So for that, okay, let's stop it and I've just built the class again. Okay, build is working fine. So I will just do the greater W boot run. So it is working on the port 9080. So I will just try to run localhost uh, colon 1980. So you will see these much of points which I already made. So this is for bulkhead, this is for bulkhead event and whatever bulkhead name you want to give. Then the event type for the circuit breaker also. We just defined all the circuit breakers. Then we just give the name also. Let me try in the on the Mozilla because it give a better like clickable links there. So here it is a link. So if I will just try to open it, okay, this will be calling the backend A service and backend. So in this bulkhead, we do have all these four services. So I already told in the bulkhead, we just defined the thread pool, how many services you want to keep in that. So for one service, it is just kept the two services for backend A and two for backend B. So this is a thread pool it has maintained. And then we come to the circuit breaker part. It is just defining, okay, this much is the failure rate. This is the, for the backend A, it is a configuration. This one. For the backend B, this is the configuration. Like this. And, okay, circuit breaker 1. So circuit breaker 1, I will just show a service. Backend A. I don't know what is the name I have to give. I will just check on that. And this is the stream circuit breaker events. Mm. Then this is a rate limiters events. How many rate limits you want to give? Then cache, loggers, all these things are mentioned here in the configuration levels. How many levels are there of error test debug? So this is all about the patterns for this website. So here just we just end with this explanation. If you do have any questions or you want to learn more about that, you can just comments in the comment section. So I will just be there to respond on the same. Thank you so much, everyone, for your time. And if I already mentioned, if you do have any questions, feel free to make a comment, and I will just make an individual video for each pattern with a live example. Here I've just taken a reference from the GitHub for explaining all the pattern at the same time. But I can just make a separate video for a single patterns. Thank you so much, everyone. Have a good day.